All right, so this is day one of lesson 31, which is all about trapezoids. So before we get started, let's quickly review how to find missing angles. And so if you look at your paper here, you got to kind of figure out what you can figure out. So let's say I'm going to look for A here, and I see that the angle next to it is 100 degrees. Well, I know that these two angles together make a straight angle, and I know a straight angle is 180 degrees. So I know that angle A has to be 80 degrees. So I'm going to write it there and on the line here. And I don't have to go in order. I could see the same relationship here. If this angle is 40 degrees, this one has to be 140 degrees because, again, it makes a straight angle. So D is also 140 degrees. Let's see if we can find another relationship. I'm looking for... So like if I had a situation here where I know that this one's 80 degrees, I know this right next to it is 80 degrees as well, even though that's not what I'm looking for. But anyway, just kind of go around the shape and see how many. And don't forget that all angles in a quadrilateral add up to 360, and then all angles in a triangle. So we have a triangle right here. And we know that all angles in a triangle are going to be 180 degrees. So you can use that information as well to help you figure this out. Opposite angles in a quadrilateral, in a parallelogram, excuse me, it has to be a parallelogram, are congruent and so on and so forth. Here we have an isosceles triangle, right? So in an isosceles triangle, if these two sides are marked the same and this one's 70, then this one also has to be 70 degrees. So that'll help you out. So you're just kind of recalling everything that we've learned this year. I don't know why I don't have an L on here, but anyway, that's 70 degrees. And figuring out as many missing angles as you can. If you figure them all out, come see me. I'd like to know that. All right, new information. So this is kind of what we've been talking about. We've been talking about quadrilaterals. Quadrilaterals have 4 sides. And remember, it's 360 degrees for the interior angles. All right. Now we've talked about parallelograms, rectangles, rhombuses, and squares. The reason why these are important is they have 2 pairs of parallel sides. Okay. And as we know, rectangles and squares are special cases in which all the angles are congruent, but most parallelograms have opposite angles that are congruent, opposite sides are congruent, and diagonals bisect each other. Okay. So today we're going to talk about shapes that only have 1 pair of parallel sides, and these are what we call a trapezoid. So there's 2 different types of trapezoids we're going to talk about. Just the regular trapezoid and an isosceles trapezoid. Very similar to an isosceles triangle. 2 sides are going to be congruent and the 2 base angles are going to be congruent. All right, so let's go ahead and talk about that, and then we'll finish up this unit talking about a kite. A kite is a quadrilateral in which we have no pairs of parallel sides, and we'll talk about that in the near future. So the first thing, let's go ahead and explore the properties of trapezoids. So you're going to pause this video and go ahead and label this trapezoid before we get started. We'll call it A, B, C, D. So we'll call this A, B, C, and D. And then you're going to measure each angle, record the measurements, and find the sums and see what special relationships you can discover. So go ahead and pause the video at this time and do your... You should have had plenty of time to go ahead and make your measurements. And what I discovered was that angle A equals 105, or something around there. Angle B is 105, okay? So these 2 angles are congruent to each other. And then I found that C and D, they're both acute angles. Angle C was 75 degrees. And angle D equals 75 degrees. So a little bit different because we only have 1 set. These are our parallel lines, and we're being cut by a transversal line. Sorry about that. we're being cut by a transversal line over here. This is our transversal. These are same side interior angles, which makes them supplementary. So our supplementary angles are in a different spot in this case. So the sum of A and D is going to be 180, and the sum of B and C is also going to be 180 degrees. So those are the supplementary angles. And so the base angles are congruent on the top and the bottom. All right, so the next thing it asked was, what is the relationship between the diagonals? So if I draw a diagonal here and a diagonal here, and I went ahead and measured in centimeters, I got that this was 7 centimeters, and this diagonal was also 7 centimeters. So I can say that the relationship is the diagonals are congruent. And then I also measured these legs, this leg over here from B to D, and I measured from A to C, and I actually got 5 centimeters, and 5 centimeters on this side. So this would be an isosceles trapezoid, because I also got the legs are congruent if you have an isosceles trapezoid. Okay, so now having looked at these properties, you're going to see if you can practice some problems. So we're going to find the measure of each of the angles in here. So if this is 58 degrees, then I know that angle 1 is also 58 degrees. So this angle and this angle are congruent. And now I can figure out the angles of 3 and 2 simply by taking 180 minus 58. So 122. And that's going to be both angles 2 and 3 are supplementary, and they're going to have degrees of 122. Okay. If we look at number 2, again, you can use the same relationship. I know that angle 1 is going to be 109 degrees. And then 2 and 3 are going to be supplementary, so I would just take 180 minus 109. So these are 71 degrees. And again, I'm looking at angles, not side lengths. These are all isosceles triangles. All right, and then down at the bottom, you're going to use this information, the same information, to solve your problem. So we know that these two angles are going to be equal to each other. These two angles are going to be equal to each other because they're congruent. And we know that our diagonals, so AC and DB, are also going to be congruent to each other. So if you're going to set up your equation, you would set it up like this and go ahead and figure out what x is and then plug it in. So you can do those problems on your own. Okay, so then there's another thing that you can discover mid-segment of a trapezoid. So if you go ahead and trace A, B, C, and D from above, and then you're going to fold it in half so that the parallel sides overlap, that's actually going to make a mid-segment, okay? And so what you would do is go back to this trapezoid here, okay? And you're going to trace, fold it in half. So it looks like it should end up right about here. And that's going to actually cut your trapezoid in half. But you would fold it and do that. And what you should notice is that this side is going to equal this side. And this side here is going to equal this side over here. Let's see, where were we? Okay, so so what I actually discovered when I drew my mid-segment is that when I measured all these, I got about 3.7 centimeters for the top from A to B, and I got 6.3 from C to D. And then what I noticed is that my mid-segment was 5 centimeters. And what I noticed is actually that is half of AB plus CD. So AB was 3.7 plus 6.3, that's 10 centimeters. And then I found that the length of the mid-segment was 5 centimeters. So I can conclude that the middle is going to be half these two added together, or we could say that 2 times the mid-segment equals the leg plus the other leg, okay, or the top plus the bottom, I guess I'll just call it. The top plus the base, all right? So 2 times the mid-segment is going to equal the top plus the base. So how would I set up my equation? I would do 2 times 3x minus 6 equals, this is the top and this is the base. So 2x plus 2x minus 1, excuse me, minus 1 plus 25. And then you go ahead and solve this equation. So I do have to do the distributive property. So this would be 6x minus 12 equals 2x plus 24. So now I'm going to see that I can subtract 2x over here. And that's 4x. And then I'm going to add 12 over here. And that is 36. So x equals 9. And then if I plugged it in, I would notice that the mid-segment times 2 would equal the sides added together. Okay, so you're going to use the same formula to solve for x in the other 2 formulas. Please remember the mid-segment, it's going to be the middle times 2. So this is the mid-segment times 2, and then add it to the other sides. Looks like number 4 and number 6 are the exact same problem. Okay, so now we've discovered quite a bit. And we've got 2 handouts, so if you weren't here, you're going to have to ask me for those 2 handouts so that you can go ahead and practice the properties of isosceles trapezoids. Actually, let me look. I might have actually put these in your packet for you, and I sure did. So you're going to go ahead and complete pages 12 and page 13. It looks like the only one that you need to ask me for is page 218. So this activity 4 is not in your packet. All right, good luck. One more thing I wanted to point out for you when you're working on page 12 is that I'm going to go ahead and draw a rough sketch of what it looks like. It looks something like this, okay? And then you've got your mid-segment here, and then you're looking for B, C, D, A. Please note that this is how you mark parallel lines. These 3 lines are all parallel to each other. So if you know that this is 16 and this is 12, obviously this drawing is not right, you can add these together, 16 plus 12, which is 28, and take 28 and divide it by 2. So this midsection here is going to be 14, okay? But what I wanted to point out is if you know that this angle is 42 degrees, and this angle is 63 degrees, okay? And these are parallel lines, and this is a transversal. Well, then you know that angle A here is also going to be 42 degrees. And you know that angle B here is also going to be 63 degrees because you got parallel lines cut by a transversal. Now, when you're looking at this angle here, these are parallel lines cut by a transversal. These are same side interior angles. So this one is going to be 180 minus 42. Just so you know. And so 180 minus 42. And this one over here is going to be 180 minus 63. So this clearly is not a isosceles trapezoid, but you can in fact find the degree. So 180 minus 42 is 138, and 180 minus 63 is 117. Okay, so now if you add 138 plus 117 plus 42 plus 63, you should come up with 360